All of us in this room are lucky to have a strong and well-built immune system which protects us against the million microbes that we encounter every day. Have you ever thought about the germs that cover the handle in the bus you take to work? Or the pathogens that sit on the pen or pencil that you sometimes subconsciously put in your mouth? Well, yeah, our immune system can quickly detect the invading microbes and trigger an immune response against them. Imagine you're sitting in a packed hockey arena watching a Canucks game. You're enjoying the game and the Canucks are outplaying their opponents. Yet you're unfortunate to catch a flu from your neighbor who has one of those awful seasonal flus. After encountering the flu virus, your immune cells will be activated to kill and eradicate them. And you will hopefully feel normal in about a week. But what happens next? Will the immune cell remain active? The answer is no. And in fact, it is absolutely crucial that they go back to their resting state. But how does the immune system shut down? Interleukin-10, or IL-10, is the master switch that turns off our immune cells. Okay, let's think of the immune cell as a hockey arena, and the proteins which make up the intercellular signaling pathways are the hockey players. Within the cell, a specialized proteins called transcription factors, such as STAT3, try to get into the nucleus and to turn on anti-inflammatory genes that are needed to shut the cell down. So prior to my studies, it was thought that IL-10 activates STAT3 and that the STAT3 is sufficient by itself to inhibit inflammation. But we found that just like Daniel Sedin, who scores more goals with Henrik assisting him, STAT3 also requires a playmaker called SHIP. Now SHIP is a signaling protein that usually hangs around the cytoplasm. But unexpectedly, we found that SHIP actually accompanies STAT3 to the nucleus. Once there, just like the Sedins, STAT3 and SHIP work together to get the puck to the net. So what is the importance of my work? Well, we can use this knowledge to treat inflammatory diseases. Since STAT3 and SHIP work together, we can use the drugs that we have developed to activate SHIP to turn on STAT3-regulated anti-inflammatory genes. In fact, SHIP activators are now in human clinical trials for treating inflammation. In conclusion, if our team lacks either Henrik or Daniel, we will get terrible inflammatory disease and lose the game. Thank you.